Roz Naylor is a Stanford alum and the William Wrigley Professor of Global Environmental Policy in the Doerr School of Sustainability. Professor by courtesy in economics and founding director of the Center of Food Security and the Environment at Stanford. Her research focuses on policies and practices to improve global food security and protect the environment on land and at sea. She's been involved in numerous field-level research projects around the world with her students and has published widely on issues related to global food systems, food policy, and aquaculture. She's the co-chair of the Blue Food Assessment, which is an international initiative aimed at providing comprehensive scientific evaluation on the sustainability, nutrition, equity, and justice dimensions of aquatic foods, both freshwater and marine environments, and how that's within the global food system. She's a fellow of the Ecology Society of America, a Pew Marine Fellow, and a Leopold Leadership Fellow. Professor Naylor is the president of the board of directors for the Aspen Global Change Institute, and a member of the Scientific Advisory Committee for Oceania, and also a member of the Forest Protection Advisory Panel for Cargill. At Stanford, she teaches courses on the world food economy, human society, environmental change, and food insecurity. And in her free time, which I hope she'll be getting more of soon, Roz spends most of her time with her family and friends in the mountains, skiing, climbing, hiking, biking, and swimming. So without further ado, I'd love to pass the baton to Ms. Professor Roz Naylor.
Thanks so much, David. This is so fun to, I wish I could be in person with all of you, because I see so many familiar names of students who I've taught, as well as colleagues and friends, and it's just so fun to be able to do this inaugural lecture. So I'm truly honored. And I'll just get started. We don't have much time and there's just so much to talk about. I'm going to be talking about fishing for sustainable food options. And this photo that we purchased as part of the Blue Food Assessment is in fact a real photo looking down at a coastline, part of a coastline in China. And it's incredible, the use of the oceans for food production in some areas. And so that's one of the issues that I'm going to be talking about. But before we start, I wanted to just give a little bit of history of where we've been on sustainability at Stanford and where we're heading now with the Doerr School, the Stanford Doerr School on Sustainability. Many of you who are online were with me at the time when the Center for Environmental Science and Policy sprung up under the Institute for International Studies. And within that, we started the Goldman Honors Program in Environmental Science, Technology, and Policy. And I'm seeing a number of you from the Goldman Honors Program days, and all of you are doing such amazing work. And so it's really neat to have this alumni base here. And we have gone on from there to form, as institutions changed at Stanford, to form the Center on Food Security and the Environment, which sits under the Stanford Woods Institute, as well as the Freeman Spogli Institute for International Studies. So really the work that I do and my colleagues do is campus-wide, and it's just amazing to interact with faculty from all over campus. And that indeed is the goal of the Doerr School, is to really engage faculty and students from all different departments in thinking now about sustainability. So what I'll do is just start with the challenge as we think about sustainable food systems. I mean, what we're really challenged with is meeting a rising demand for food that's driven by population growth and income growth and diversification of diets, but doing that and while we're managing resources and the environment in an era of climate change. So it's a very dynamic and challenging system. And the photos, the types of droughts that we're seeing on the top. I love the second photo, which is a farmer in Indiana at the exact same time in two adjacent years, subsequent years, with one being very high yielding, high rainfall, very low yielding, low rainfall. And so farmers are facing enormous challenges with regards to heat and drought. And of course, big areas like India overpumping groundwater and the challenges surrounding those types of issues. But on the food side itself, I think we're really increasingly challenged by nutrition security, how to provide nutritious diets lower obesity and malnourishment, which tend to go hand in hand in many cases. So it's quite a challenging environment. And I like to think about it in an interconnected global food system, where the demand for food is driven, as I said, by population and income growth that is leading to more demand for animal protein, but also using our food systems for fuel, biofuels. And that demand will be supplied by a range of terrestrial crops, terrestrial livestock, and inland freshwater aquaculture, as well as marine fisheries and aquaculture. And all of these different food systems are interacting, crops being a feed to livestock and aquaculture, fisheries also being a feed for livestock and aquaculture, and a lot of substitution between crops. And so economics plays a very important role in all of this. And of course, it's conditioned by the types of technology that are being developed, the natural resource base that we face, climate change, and very importantly, yikes, I can't go back. So very importantly, by policy. So what I want to do today is delve into a couple of field level projects and just give you a sense of the work that I do and the challenges that are presented, and then talk about some of the solutions that are out there. And I'm sorry I missed some of the mediating slides there. I tend to think about this in a very holistic view. Some of you have studied this idea of donut economics, of really preserving the social base of food. What we are looking at in that left-hand picture is we want food in the end, and we want nutritious food in the end. It's not just about increasing the volume of agriculture production, which typically the ministries of agriculture or the ministries of fisheries might aim for, is just more production or more income, and not necessarily the vitality of the system and the food that we eat. So the goals are very important. And my work started way back when I was a graduate student at the Food Research Institute. And I did see a few people online that mentored me in that program, which was very fun when we were looking at the rice economy of Indonesia. And the goal in this early period was really just to think about providing enough production for basic calorie needs. Widespread calorie deficits throughout many parts of Asia, Africa, and even Latin America. So the goal was just really to increase production. And this led later to my professional work with colleagues in thinking about increasing production in a more sustainable way. So the goal here being, can the world feed a population of potentially 10 billion or more without destroying the environment? And I love the middle shot here is my colleague Pam Matson, who I worked with for many years in Mexico in the Yaqui Valley, and several other of my colleagues from the Yaqui Valley are on this call as well. And we were really focused on Green Revolution. This was the home of the Green Revolution for wheat, where Norman Borlaug got his start. And just incredibly high rates of fertilizer were being used to achieve the yields that were targeted here. And Pam Matson and her group was really interested, how do we manage agriculture to reduce nitrogen and reduce the environmental impact? And I was really interested in what does it mean for farmers and their incomes and profitability. Because although we want sustainability, it's absolutely important that farmers are able to earn a livelihood while they're producing their food. And nitrogen is one of the dynamic nutrients in the system. It moves around a lot. It contributes to greenhouse gases, nitrous oxide, very important and potent greenhouse gas, but also to water pollution in the form of nitrates, or air pollution in terms of NOx. And so it has huge costs to the environment, but it also has a lot of cost to the farmers, because if the plant is only taking up 40% of the nitrogen and then losing the rest to the environment, if you can manage it better, it's definitely more profitable for farmers too. And that was our goal early on, is designing our research so that it was integrated from the start. And we were thinking about the environment and farmers going hand in hand. Of course, the Green Revolution had other impacts and other chemical use, especially pesticide use. And this graph down below really starts in the 1990, but pesticide had been increasing globally quite a bit prior to that with the Green Revolution. And the slide just shows the global cost of this, even finding pesticides up in the Arctic, in the animals that some of the natives eat up there. And it's very widespread. And I would say one of my biggest concerns in intensification of food systems is the toxicity of those systems, given the chemical use. And of course, one of the options is all of the modern genetics that we have, genetic engineering in terms of genetic modification, bringing in foreign genes into plants, which is highly controversial in many places. But there's modern techniques like gene editing, the CRISPR, as well as bioinformatics. And this is a really important part of the toolkit. And if we don't acknowledge the importance of genetics and what we can do to maybe avoid the harmful chemicals that go into the system through advanced genetics, we're really missing a big, important part of our potential for sustainable agriculture. Of course, organic is another part of the answer. And just to give you a sense of how important organic is, about 75 million hectares are farmed organically now out of about 5 billion hectares globally. So it's a small percentage. The US has the largest organic market. About 6% of our market is organic, and less than 1% of our farmland is organic. So we still have quite a ways to go, although this trend is moving definitely in the right direction. And especially with CRISPR and other genetic techniques, I think can move more quickly in that direction. Most of the producers are in Asia. 90% of the organic producers are in Asia, Africa, and Europe. And this is really an important point because Europe cares a lot about GMOs, obviously, but Africa, a lot of those organic farmers, they just don't even have the money or the access for the chemicals in the first place. And so I have met with African farmers who are quite destitute, and they don't want to necessarily be organic, but they are. Okay, so there's a wide swath here to talk about. The second example of my work I wanted to bring up was in the oil crop sector. And this is a picture of palm oil. This again in Indonesia. I've had quite a long run of research in Indonesia, starting from my graduate days. Indonesia is the largest producer and exporter of oil palm. It competes in the market with soybeans and canola, rapeseed, sunflower seed. But there's a huge demand and growing demand for fats and oils. And so what we see, the forest transition that we see with palm oil here in Indonesia or soybeans in Brazil, parts of Latin America, is going, the pressure still going to be on. And so our work was really looking at the rising demand for oil palm as an important part of the food base in Indonesia, but also an important export opportunity in terms of export taxes and revenues from foreign exchange. Huge impacts on land use change and biodiversity. And a lot of the land clearing is done by fire. So there's air quality issues regionally, obviously contributing very importantly to global climate change. But very strong political interest to maintain this sector. These trees are in the ground for 25 years, and it's important for government revenues, and it's important for livelihoods as well. And so how do you balance these things? We had a long study where we actually conducted a randomized controlled trial in Kalimantan with 400 villages. And it was incredibly fun to be riding up and down rivers and visiting these villages and being on motorcycles and getting stuck in villages and sleeping. I mean, I love field work. And our work, we were trying to provide a positive incentive to villages because villages manage the resources to not burn. And it was very challenging given the diversity of villages in our system, but very enlightening in terms of the widespread interest in reducing. And I would say that the bottom line here is that I don't think the amount of money that we paid villages was enough to get to enforce stoppage of burning. But it also enforced the notion that you need carrots and sticks at the same time in this situation. So another example of my work has also been in the livestock, terrestrial livestock, and other animal food-based systems. And again, the picture on the left is the United States and the nutrient loss, not only from crops, but also from livestock that we see in our systems and many systems around the world. The picture of hogs, their swine in China. China is such a huge importer of pigs and hence a big importer of soybeans as well. And so these systems are big and dynamic and drive a lot of the cropping systems as well as the environmental issues that we see in terms of greenhouse gas and pollution. And so one of the questions is always, what is the role of plant-based animal foods? Currently, they contribute, they're projected to contribute about 5% of the protein in this decade. So we still have a lot of protein demand out there that's going to have to be met by other sources, unless there's a huge behavioral shift away from wanting to eat some kind of meat or synthetic meat. And what's interesting to me, I've been taken a real interest, and I'm a fan of the cellular meat idea, but the market has been tanking lately. I mean, some of the major companies their stocks have really been falling, and so whether the demand holds up will be a very interesting and challenging proposition. And that's why I do want to introduce fish into the system today. So moving beyond these kind of staple grains and oil seeds and livestock into aquatic foods is something I want to talk about. It's really been challenged in terms of political interest. There's a lot of vested interest in staple crops, whether we're talking about wheat or corn or soybeans in many different countries, or we're talking about livestock interests. And so even thinking about fish and aquatic foods as part of our food system isn't even in the political lexicon of many countries, including the United States. I mean, they're just starting to think, what is blue foods? And we think of it as managing resources, but not as a food base. So that is the goal that I want to talk about. And so I think that we have been forgetting aquatic foods overall in our discussion of food systems and sustainable food systems. When we look at the demand just over the period 1990 to 2020, a huge increase in the consumption per capita from 13 to over 20 kilograms per capita. And then obviously we have added many more capitas. So we have a lot of growth in this industry in terms of demand, and aquaculture has been meeting most of that growth. So this is part of our Blue Food Assessment, and which David mentioned in the introduction. The Blue Food Assessment started in roughly 2019. So we've had a series of studies and papers that has involved people, more than 100 researchers from over 25 institutions. It's a huge international initiative that has been co-led by Stanford and the Stockholm Resilience Center at the Stockholm University. And the Eat Lancet group has been our sort of outreach collaborator. So I have co-chaired this Blue Food Assessment with Bia Krona from the Stockholm Resilience Center. And we've published 9 different papers in different Nature journals on everything from the nutritional aspects of blue food to the environmental and climate change, vulnerability and impacts, to equity and justice, the role of small scale producers, what's happening on the demand side, and just thinking about transformation in this sector to make it more sustainable. So it's been a huge effort and a very productive effort in terms of the studies that have come out. And we're now in the next round of where do we take the Blue Food Assessment. So in terms of nutrition, fish are rich food for poor people. That's a slogan that I heard many times when I started working with my graduate student in Kenya. And they rely on fish more than any other animal food source for important micronutrients as well as for protein. And so I would say rich food for all in terms of not just the protein, but iron, iodine, calcium, zinc, vitamin D, long chain omega-3 fatty acids. So the nutrition study showed that relative to other forms of animal protein and plants, you have you've just got a micronutrient dense package ready to give people in even very small amounts. Putting one fish in soup or fish powder in their meal can really add quite a bit to people that are seriously malnourished. And I love this picture on the left that I took in this market in Kisumu in Kenya, because what you're seeing there is 3 forms of Nile tilapia. One is coming from Lake Victoria, it's wild. One is coming from their new farm projects of increasing aquaculture in this region. And the other is imports of Nile tilapia from China. And in fact, the Chinese imports are making their way into these remote markets in Africa and actually outcompeting the Chinese producers. And so this is a really complex terrain and a very vibrant international one. So when we look at the growth of fish, and aquatic foods are defined by both cultivated and wild capture of fish and shellfish, algae, which is the seaweeds, as well as aquatic plants, mainly in freshwater systems. But when we look at fish, you can see the blue is coming from capture fisheries, mostly in marine systems. The dark are in freshwater. And then the pink or the red are coming from aquaculture, and the darker are coming from freshwater. So we're really seeing this huge hidden revolution in freshwater aquaculture over recent decades that is actually supplying huge amounts of food and nutrition, especially in Asia, to populations in both rural and urban areas. And so I've worked in these systems in Indonesia in the top, and on the right in China, and the bottom in Kenya. In the middle one, Bangladesh, I have not worked in. We've purchased that photo. But as you can see from just the growth of aquaculture relative to all other kind of commodities, it's just been skyrocketing. And these are in live weights, but you've seen huge growth, especially relative to terrestrial livestock. You can also see the growth of oil palm and why I was interested in working in that. So let's talk about some of the challenges, and I'm just going to mention a couple so that we have plenty of time for discussion here. One of the challenges in aquaculture that I've worked on from the start for the past 20 years has been the use of fish in aquaculture feeds. And so the question early on when I started this work in the 1990s with a group of colleagues from Stanford and internationally was, are we adding or subtracting to global fish supplies by actually growing out the aquaculture sector? And this is a picture of a tuna operation that one of my former students took in Australia, but almost the whole catch of sardines from say Monterey Bay can go into feeding this system. And so you're transporting wild fish around the world for these kinds of systems. But there's a wide variety of them, and not all fish that are farmed eat wild fish. So there's a lot of nuance here as well. So what we've seen over the past 2 decades is the feed conversion ratios in aquaculture have improved across all fed species. And more aquaculture, whether it's freshwater or marine, are being fed feeds now. It's like the industrial livestock sector. It's following that model of intensification, using commercial feeds to actually improve productivity. But the fish meal protein that I showed you from that prior picture has been replaced by plant and animal protein trimmings and fish processing, trimmings from fish processing plants. And so a lot of waste from one industry is being used as the input in feeds to this sector. And so you're seeing fish and fish meal inclusion also dropping due to genetic improvements in these animals that are being cultivated. So we had used an metric of fish in to fish out. And when we started the work in 1997, it was fish in to fish out was 1.9, meaning that you needed 1.9 kilograms of fish to produce 1 kilogram of farm fish. So that's not a very good fish in and fish out ratio, but you can see how dramatically that has fallen up until 2017 in terms of the global fish supply. We are now only 0.28 kilograms of fish and feeds going to 1 kilogram of farm fish. So enormous progress technologically across many domains here. And I'll say, when you look at what goes into feeds, you may not like this when you're sitting down to your next meal, but in fact, producers of livestock and aquaculture are looking at a range of commodities that they're putting in their feeds. It's like a big linear programming model, and they're deciding what provides the best nutrients at the lowest price. And so you'll see all these processing waste: feather meal, dry distiller grains, soy meal, bone meal, corn gluten meal. So at different prices, and anchovy meal, from like that first picture, is the most expensive. So these producers are going to substitute into, say, feather meal from a chicken processing plant now. Okay, so this has all happened. It's a very now integrated system and circular system where there's much tighter connections between land and sea. And so as we grow out aquaculture, and this is a yeller croaker farm in China, one of my students is working in that area now, they'll depend on fish meal and fish from the oceans, but they also depend, say, on soy gluten meal, and so, or soy protein meal, which might be coming from the Amazon. So it's just more complicated, but it's all connected. And I would just say that the commercial animal feeds in aquaculture is still pretty small relative to what we see in commercial systems of poultry, swine, and beef, which are using much more of the commercial feeds. So I also just want to point out that as we intensify aquaculture to meet the needs, so we're thinking about two things here. One, if we want to avoid depleting capture fisheries, aquaculture is likely to be one of the big solutions here. And our hope is that it's done sustainably, right? And so to meet the demand and not overfish wild capture fisheries, how are industries actually doing that? The part is in the genetics of just enabling these fish to grow faster. So one of the big policy debates in the United States has been allowable permits for genetically modified fish, that is taking genes from other types of fish and putting it into an Atlantic salmon to grow twice as fast in a shorter amount of time. And so if we're really going to meet, I told you genetics coming in, and it's coming in fish. It was the first animal food to actually be approved for genetic modification. It was first produced in China, up in Canada and in Panama, and now it is permitted to be produced in the United States. But you'll see much more of the CRISPR kind of gene editing, I think, in this field going forward. And very importantly, you'll see much more of the genetic tools being applied to prevent disease and other problems within aquaculture that might enable us to move away from a lot of antibiotics and antimicrobials, which are quite damaging in this field. We're also seeing genetics in the feeds that are being used, especially in aquaculture, the use of genetic modification to enable, in this case, canola to have long chain fatty acids. So some of it is going into the feeds as well. And lastly, I want to talk about, just mention some interesting kind of innovations that are surrounding the need for feeds in aquaculture. This is a company, Callista, that started in our area here at Stanford. And what they're doing is they're capturing methane from natural gas pipelines, capturing the methane that's being blown off, transferring it through methanogenesis into a fish protein that can be used in feeds. And so this little table down below is showing the protein content can be higher than fish meal, the shelf life can be longer, and it's quite promising, but they're doing the life cycle analysis of this whole industry. But to me, it's really interesting. Now we're even capturing waste from an energy source and putting it into feeds. So I'll just conclude this section. There's so much more to talk about that overall, I would say that the aquatic foods are generally, the environmental footprint can be sustainable, but not necessarily all the time. And I think that it's really important to be nuanced here. First of all, capture fisheries have the highest greenhouse gases, and they're also leading to overfishing in a lot of areas. But there are well-managed areas as well. And so understanding that nuance in the capture fisheries is important. Aquaculture can have high water and land use, also can lead to greenhouse gases through feeds. And the main aquaculture systems that are commercialized are competitive with industrial poultry in terms of greenhouse gases. So there's overfishing threats. The biggest worry I have right now at the moment with aquaculture is the quite unregulated antimicrobial use in aquaculture worldwide, not in the United States, not in Europe, but in many countries of the global South where the growth is the fastest. So on that note, I want to get to our conversation and Q&A. So when I think about the path forward, I would urge my students and colleagues to really think carefully about navigating policies and politics in the food system. It's so easy to just say, oh, let's just change the Farm Bill or just change these policies. There's usually very deep historical precedent in food policy in countries that might have sprung up from the need to achieve food security at one point in time, the investments that went into that sector, the vested interests that develop in that sector. So in the United States, the fact that we have 2 senators from each state, representing rural areas, there's a big agricultural representation there that will remain. So we do have the Farm Bill is our biggest omnibus bill here in the United States, and it's filled with politics. And so understanding that to me is one of the most fascinating parts of agriculture and food systems. But we have this potential, secondly, to build the circular economy. And I've tried to give examples of where we use waste from one part of the food system as an input to another part of the food system. And the more we can do that in an energy efficient way and in a food safe manner, I think is going to be the key to actually meeting food demands. We can't have half of our grains going into feeds and all that land. There needs to be much more achievement with the circular economy, and the progress in this area is phenomenal, actually. And then the last point that I would make here is on transferring knowledges and best practices. We saw this going way back to the Green Revolution, when the CGIAR was formed to transfer knowledge to developing countries on the transfer of high-yielding seed varieties and input packages to increase yields. But now it's more challenging. How to manage pests and pathogens without using really harmful chemicals, pesticides, and antimicrobials. How to manage land use and water use. There's a number of knowledge-based practices that I think we need to get also on top of. And these are more tricky and are more behavioral in nature. So finally, what about the Doerr School? I haven't really talked about the Doerr School, but how will the Doerr School help in a situation like what I'm talking about? I feel really privileged to be a faculty member in this new Doerr School of Sustainability. It's just an incredible opportunity right now for a couple of reasons. First, I'm an economist by training, as was mentioned, and we're adding quite a few right now, and in the next 10 years, quite a few faculty positions in the social sciences pertaining to sustainability. So in the Global Environmental Policy Department, the Environmental Behavior Department, and these are new departments where we're actively recruiting a wide range of faculty. And so I'm just so thrilled. I can't wait to work with the new people that are coming in. And the process a little slow, but because that's the way it is with faculty hires, but it's really very promising. And so students will have many more people to choose from besides myself and a handful of others working on food on campus. The second is that the Doerr School has supported this accelerator program where they're taking ideas and scaling them quickly for promising ideas. Of course, there'll be a lot of ideas that fail, like the startup business, and they'll stop being promoted, but there'll be a handful that really go somewhere. And the idea is speed and scale of just putting ideas out there and supporting faculty to partner in ways that can get our ideas out into the real world and into action. And I do have one of these accelerator grants on building a global environment facility program for building out aquaculture in Africa. And that's going to be really fun and pretty challenging, actually. And the last is that there's a set of initiatives. And I'm hoping that the Doerr School will support an initiative in food systems that can cover a range of the issues that I've talked about, from chemical use to plant-based meat alternatives to aquatic foods and terrestrial foods. So this would engage new partnerships, provide a lot of student support and faculty support. So on that, I'd love your questions and we can have more of a conversation. So thank you. And I think David will moderate and I'll just answer the questions.
Yes. Thank you very much, Professor Naylor, for that great talk. I do want to start and get right into questions here. Thank you for everyone who's been submitting questions in the chat and directly to me as well. Really appreciate it. Let's kick it off by asking, and we can keep you pinned here. How do we balance aquaculture's capacity for high production to meet food demands, but also the need to grow more genetically diverse species for, coastal repopulation and just kind of keeping our fisheries healthy? And are you seeing any good examples of those kind of balanced approaches to food production in that way, or are those kind of separate initiatives from your view?
Yeah, it's a really important question. There, one of the big parts of the competition here will be when aquaculture is in natural habitats that are supporting wild fisheries and diverse wild fisheries, whether it's in freshwater systems or coastal systems. That can be that can be in direct competition if they're destroying the habitat. And so one of the policy recommendations that I've really emphasized, I just finished a huge review of aquaculture policy around the world. And one of the key points is on siting. And if siting policy, where you put aquaculture and how it interacts with wild fish populations, if that's not done well, you're going to really lose out on that last question. I think what's happening in aquaculture as well is it's incredibly diverse. There's about 680 different species that are farmed around the world. And a lot of these aren't even they're not even identified. They just go under not elsewhere identified category. And so there's still much more diversity in aquaculture than there is in our terrestrial livestock and crop systems, for example. And some of that has to do with just in a situation, say Bangladesh, they just started taking capture fisheries and putting a net around the river and raising those fish that swam into that net, very much like the traditional Hawaiian approach. But what we're seeing as aquaculture matures is that it's much more investment in a handful of species: shrimp, salmon, tilapia, catfish. Those are the key ones. And you can understand this from the sense that there's much more genetic investments. These are big capital investment. And if producers are going to grow a species, they're going to want a species that's been tested and tried and know that it has not going to fail, not going to have a disease, not going to, just tank right away. And so I do worry it's going to be much less diverse going forward as well.
Thank you for that. Oh, and by the way, you're allowed to not share your screen anymore. I think it allows us to all see each other too.
Oh, good.
I'll bring some of these questions as well too on back to the land a bit. We'll try to do land and sea as much as possible. This one's a little bit more universal, and it's really kind of looking at the conversation around food waste, and both on a policy level and kind of what you've seen from like a life cycle analysis, how some food waste or byproducts can be reincorporated into a more circular approach. And then we also see how food waste can also still meet the demand for food from humans by, limiting the waste throughout the process in agriculture. And I wanted to talk to you a little bit about that, ask you to see what you think the opportunities are within the food waste space, and also maybe if there's anything that you are aware of within the School of Sustainability, if those are areas of interest that you guys are looking at.
Yeah, that's a really good question. And I hope that if we can develop an initiative on food systems, that it would include that topic, because it's so ripe for technology advances as well as different behavioral and supply chain advances in how we organize supply chains. Some of the even the types of innovations that have come up from former students from the business school, for example, they've just created information platforms to connect producers to consumers, so they actually know when to harvest more perishable crops. When we think about nutrition security, a lot of nutrition rich crops are highly perishable, and so that's another reason why farmers prefer the more staple non-perishables, is that they store easier, but not necessarily as nutritious. And so if we can connect producers to consumers through technology, as well as to think about just the use of the wasted part as an input in another part of the system. So if parts of the system are not gleaned and are remaining in the field, could that actually be used as an input for feeds or whatever? So these are all highly, really good potentials. The technology has to work, the economics really has to work. And it's such a diverse area that I think the economics really does have to work. I think the mindset, the behavioral side of this is moving in the right direction, where people are acknowledging food waste now, that we see even in restaurants. Fats are going into gas tanks, and we're seeing the use of waste going down quite a bit. And I think even in the United States, I've had so many conversations since I started the Blue Food Assessment with chefs who don't want all this waste and are thinking about even how they design their meals and the size of their meals and everything to reduce on the consumer side. And so there's a technology part, there's a behavioral part that needs to be supported, and just the economics, has to work for producers and for those processors that can utilize this material. So it's just ripe for so much innovation. I don't know of anything happening yet to grow this out, but it's part of our discussions on starting a food system initiative at Stanford. So anybody who's involved in that, please come our way. Yeah.
And, there's another question that has kind of come in the mix, and just thinking about we talked a little bit about nutrition, meeting both demand and also nutritional value. And then, there are some folks that would say that, we can't ignore the soil's ability to be able to provide, not only sequester carbon, but provide nutritional value that comes from microbial life. And how do we kind of balance optimizing kind of soil health with also meeting food demand is something that I think had come up because, especially when we think about, let's say, hydroponic aquaculture or aquaponics, excuse me, where, we're driving down the use of water, but and not utilizing soil, which is looked at as a positive benefit. But there are other ways to nurture soil as well, too. And so I know that these are kind of somewhat disconnected, but when we look at meeting food demand, they kind of come together when evaluating a hydroponic aquaponic system, offshore aquaculture, and something that kind of integrates both coastal, soil health on the coast and water quality. So I just kind of not necessarily a specific question, but how do you look at kind of balancing the conversations around soil health, water quality health, and meeting food demand? Yeah. What keeps you up at night there?
Yeah, well, yeah, it's a great question, and we're pretty lucky for those of you who have, studied under someone like Scott Fendorf and taken a soils class. And obviously the nutrition in the plant depends on the nutrition in the soil. I mean, there's a direct connection there. And if you have dead soil, you're going to be just augmenting with different fertilizers, but you're going to miss a lot of the micronutrients in particular. And the soil health is so important just in terms of all of the action of a regenerative system, for also enabling that whole agricultural system to be an active in sequestering carbon and producing food for people and everything else. So this whole regenerative idea depends very importantly on soil health. So luckily we have colleagues here in the soil area that do good work. But from my perspective, one of the reasons I'm really worried about the toxicity and the management of these crops is that, we're killing a lot of this stuff. We're killing it by overplowing, and we're killing it by just a lot of toxins that we're putting into these systems. And that's why I'm personally more open to some of the genetic approaches to managing pests and weeds and pathogens and so forth, so we don't have to dump all these toxins in all the time. So that's another important point. Managing agriculture more generally in an integrated way, I think, is going to become more and more relevant, and everyone's going to see the value of this, where you're having nitrogen fixing crops associated with other non-nitrogen fixing crops and more integrated systems overall. It's not how our food system is set up politically, really. It's set up to maximize production of certain crops and, with different interest groups. That's at least true in many parts of the United States, but agroforestry and many of the integrated systems are taking hold in other areas of the world that I think is very important to support.
Yeah, that's excellent. And brings me to actually a follow-up question when we're thinking about, integrated systems, multi-trophic aquaculture or fisheries as a potential. Let's talk about the organisms that don't get as much love. Like, how about seaweed, and how seaweed aquaculture has been playing a pretty big role in finding a number of applications, but also with, are there any implications as well into fish feed that you're also seeing from the rise in seaweed aquaculture, and certainly too on the bivalve and on the bivalve front, have you seen any kind of rise in shellfish production that are also known to provide ecosystem services such as water filtration, et cetera, that can be added to kind of mitigate some of the negative impacts that you mentioned?
Yeah, both are in that sustainable food category, the seaweeds and the bivalves. And bivalve, just to give you a sense, when you look at the growth, it's often measured in live weight, and seaweeds is almost all water and bivalves is almost all shell. So what you're getting out of the actual production in terms of the food on the plate tends to be much less than people say right now. Okay, so there's quite a bit of hype around some of this. Now, bivalves are incredibly nutritious, and in their particularly niche and more localized production areas, it's a crop or a production system you want to support, okay, because it doesn't add a lot of environmental impact. It does have some food safety issues, obviously, if it's produced in areas that are contaminated, because they're going to pick up all those contaminants. But by and large, they're really environmentally sound. And you're seeing a place like Chile that has long been a fishing, had a lot of fish in their own diets, but is now growing a lot of mussels, shipping them to Europe and so forth. So you're seeing these big industries develop as well. On seaweeds, most of that market's dominated by China. Indonesia feeds into that industry as well, but it's an amazing concentration there. And most of the products are not actually food on the plate. You'll see food on the plate in parts of Eastern Asia in particular, but by and large, the product is used for all sorts of industrial purposes, including like the substance that you would need to ensure that frozen chicken doesn't crystallize. Just all this stuff. It's an industrial product too. So the big challenge with seaweeds is helping producers get to the market and ensuring that they have a good market that's high valued. The value proposition hasn't been high enough yet for farmers. It's almost like you need a refinery approach where the seaweed goes into one place. You would see this for corn in the Midwest, for example. It'll go into one plant and they'll take out the food. The rest will be used for other purposes. And you'll get the full value out of each ton of seaweed. And then it gets dispersed to the users of that. That could really add value. There's a number. I was just surprised when I reviewed this. There's so little genetic improvements in seaweed, like relative to all other parts of the food system. It's really lagging in terms of genetic improvements, very susceptible to diseases. It still has some production problems like that. And so the producers really do need a value proposition. So there's huge potential to improve this area, let me just say, because it does tend to be sustainable. And then you make the decision of where you want it. If you see the big systems in China, you'll see hundreds of kilometers of coastline just dominated by seaweed production. It's all along the coastline. There's not much room for the natural systems there, but it's high productivity in seaweed. So no free lunch, but a lot of promise there.
Thank you for that. We have maybe a couple more questions left. I think we'll bring it back to kind of the consumer end of things. So what do you think or just in the supply chain, what do you think the role of right now, or how have you seen the role of grocers in the United States or the UK on encouraging kind of the production of sustainable aquaculture products, or filtering, for those products and just kind of the standards of that, and what do you think that other like kind of mega consolidator groups have to play in terms of a role in this? And are you seeing, how are you seeing some of their engagement with promoting sustainable blue foods?
Yeah, really, I think they play a really important role. The large retailers that have a large market power can really dominate how either aquaculture producers or capture fishers or farmers, livestock growers are producing their food, because if they know they're going to have a large market. So if you go into Walmart, I mean, they've made a big effort on a lot of these fronts, and people do care about organics, not just from the environment, but their food safety aspects of it. And it does link to environment, not in every single way. I mean, you can still have a lot of nutrient loss in those systems, but you're going to get away from the toxicity in those systems. And they really have the potential, I think, to create a market. This would be the same as the seaweed market that I was saying. If you can create a value proposition so that producers commit to doing things more sustainably, they will. And you've seen that with Walmart, Costco, Safeway, a number of these big retailers in the United States that create these big markets. So that value chain, I was going to actually show a photo of a value chain in my slides. I think it was one of the two slides that I missed in the beginning there, going from inputs all the way to the retailers and then consumers, because the retailers are hugely important in directing things. It's not, the organics is not all of just the the Sunday market, organic market kind of thing.
Thank you for that. That's very insightful as well. I think, and I could go down a whole path of behavior change and who's accountable for that, but we can have another combo around that. I'm curious, one last question that was here, and I think this is a good universal one, is the growth of organic, and why either sometimes it can be viewed as expensive, to grow and is definitely expensive on the consumer side. And then arguably in some other ways that nutrients are management, et cetera, and other developing areas, it could be cost effective. And so how do we look at organic food prices now? And will this always be the case of being higher? Especially since you're saying that there's not as much, kind of capture of the market by organic foods, but it can still solve some of these access issues.
Yeah, I think that it's the bang on it. It's a price issue. I mean, when I go to the market, I'll pay the price, but I think that there efforts right now to put organics as part of the SNAP program for low-income consumers, but they're really making a trade-off. There's not much money in the SNAP programs for a household, and they're going to pick the cheapest thing, and the cheapest calories tend to be not this, right? So it's a matter of scale. I mean, I look at these things as an economist where the best way to bring the price down is to bring the supply up and start, bringing the price down through just scale, the speed and scale idea that the Doerr School is really focused on. And I think that's one of the behavioral things. It's clearly a budget constraint for a number of people, but if you look at Europe, just has so many more options for organics. At least when I've gone into the market, I just see many more options and not at such a disparate price that you see here in the United States. And so, I think it just, scaling and, I also think part of the behavioral change that people are seeing in choosing foods now has to do with food safety and has to do with a better understanding of what they'll be getting out of their food. So, maybe there'll be a wholesale scale shift on this. I can't quite predict that, but.
Well, we can certainly hope for one, that's for sure. And thank you for such an insightful presentation today, Professor Naylor. I know we are out of time and we've had a lot of interest. Hopefully this is going to generate more fruitful discussions and meaningful convenings. And we encourage everyone who's attended here to join the Stanford Alumni Sustainability Group. I believe Greg has dropped a link in the chat, but thank you once again, Professor Naylor, for this insightful presentation, for reconnecting at this front.
Yeah, great to see many of you. I would like to say hi individually, but it's really nice to have you here. Thank you.